Really appreciate everyone coming up this morning to get here. This is a talk about turning emerging tech into meaningful experiences. And for those that don't know me, I'm Jed. I work for Atomic, a software development consultancy, and I've just completed a software engineering apprenticeship, which means I'm qualified enough now to give this talk, still junior enough for you to think, who is this kid and why is he giving a talk? So, why am I giving this talk today? Well, I now have enough technical experience to build something valuable. And I'm still fresh enough to have that fresh insight into the industry. I still have that fire in my belly. We're at the most exciting period in software development history. And the true winners are going to be those that can turn emerging technologies into business value. And technology has turned mainstream. How sick are we about hearing about AI now? Yet, it's still on the tips of people's tongue. So, using these technologies, it's always going to draw the right kind of attention. I haven't quite changed the world yet, but I am trying. And today, we'll be talking about some of the lessons I've learned during my 2 years in the industry. And there should be something everyone can take away with them from today. The first step in making any change is finding your why. What gets you up in the morning? What makes you wake up an hour early for work to come to a tech talk? My why sparked about a year ago when my colleague and good friend Fraser gave a brilliant talk around accessibility. There are 16 million people in the UK with some form of disability. 73% of those experience blockers on more than a quarter of websites they visit. And of the 4.3 million users, disabled online shoppers who click away from websites have a combined estimated spending power of £11.75 billion, all lost from the economy. This is an accessibility crisis, and fighting the wrong end of that battle is AI, the annoying younger sibling of technology. AI can generate and publish content online like that, accessibility friendly or not. And 9 times out of 10, AI-generated code or content won't have accessibility built in, whether it be missing semantic structure, alt text. So, what tools do we have to fight against a web full of inaccessible sites? Well, over the years, there's been some amazing innovations that have bridged this gap. Screen readers make it possible to navigate websites without having to look at it. DevTools can simulate different vision deficiencies to a certain degree to help design with accessibility in mind. And Google Lighthouse can analyse a web page and point out accessibility flaws. But how good are they, really? If you've ever used a screen reader, it's not exactly easy. Trying to navigate interactive elements, open modals, close them, navigate back through a site looking for that specific content or action you're looking for. Especially for websites that are organised like this, it's very difficult. Especially since 96% of websites are inaccessible and will break, halfway through doing any of that. So, it got me thinking. With the advancements we're making in technology, in machine learning capabilities, supercomputing, agentic AI, are we making the same strides in the accessibility space, or are we just treading water? Here's how I saw it. Technology is booming. The use of mainstream accessibility tools is increasing. I won't call it booming. And with the use of AI, the quality of accessibility in the web is bound to take a decline. And this gap in quality screams opportunity. So, what did I do when this was going through my head about a year ago? I flopped. I built an idea. I had an idea and I just started building. I wanted to combine speech recognition with a screen reader so a user could navigate a website without having to see or touch the website. In theory, it worked. It was pretty cool, but that's all it was, pretty cool. I'd missed out many steps beforehand, and this is where I learned my first lesson. Instead of coming up with many reasons why an idea will work, we often forget to ask ourselves why an idea won't work. And this is something that's psychologically ingrained. We have an optimism bias, where we tend to take in only positive things. We have a confirmation bias, where we tend to listen to any feedback and evidence that support our original claims. And we have a sunk cost bias. If we've already spent money or time in doing a certain approach, we'll continue to do that even if it's wrong. And when presenting my product to my team at work, there was one question that came up that knocked me back 10 steps. But how would the user get to the website? And this is when I realised I was merely trying to reinvent the screen reader, a product that already worked, and it already solved a real user problem without doing too much. So, back to square one. I asked, how have others innovated and succeeded? How have the world's most successful brands carved their product to solve real user problems? And asking this question led me to lesson number 2. I looked at Booking.com, a company with over 20,000 employees, over 10 billion in annual revenue, a site available in 43 languages, and over 23 million listings across the world. But where did they begin? First launched in 1996, Booking.com was only available in the Netherlands and was a simple web interface. Most hotels at the time didn't have computers, so they provided them small phones and pre-programmed modems so they could update the availability and prices on the website. So, how did this one-man startup turn into one of the most successful online travel companies in the world? They failed more than anybody else. They understood failure is feedback. Many companies launch a big product redesign every 6 months, and by the time that's rolled out, it's hard to understand what works and what doesn't. Booking's success came because they had a different culture. They took risks and embraced being wrong. They pushed small changes very quickly and used experiments to measure the impact. They started with this basic product and ran many experiments. They even built their own experimentation platform to measure what customers liked. This is when A/B testing wasn't as standardized as it is today. Thousands of these experiments are being run as we speak by Booking. How many of them prove an idea to be wrong? A few prove an idea to be very right and turn into big advantages over competitors. They are literally outfailing the competition. And this is an ideology that is heavily followed by Amazon, shown by when Mr. Bezos said this after Amazon became the first company to reach 100 billion in annual sales. Essentially saying most companies embrace the idea of invention, but they aren't willing to take the risk of failures to get there. So, I had these 2 lessons in mind. I knew what I wanted to do. I wanted to use emerging technology to improve accessibility on the web. But I still felt like I had my head in the sand. Where do I begin? And that question was answered a couple of months ago when I went to a talk at DevOps Notts. Every claim I've made about technology and accessibility today has been an assumption. And assumptions are made so they can be questioned and challenged. And that's when I learned about Wardley mapping, a clear way to map out the assumptions made around technology so they can be questioned and improvements can be made. So I sat down and I started mapping. I started with who the users are, what they need to be able to do, and what I'm capable of doing. So as a user with a disability, I need to be able to use and navigate a website seamlessly, so I need to visit a website that's developed in an accessible way. I then split out the capabilities into how standardized they are. The commodity column is for concepts and technology that are standardized and universally accepted, like the WCAG standards. The product section is for concepts that have a lot of use and credibility, but there's still a few different theories and competitors within the market. The custom built section is for emerging technology, and the Genesis column is for inventions, concepts the industry hasn't seen before. So, with this mapped out, you can then start to ask questions. Am I building something towards the left of the map when there's already a standardized tool in place for the task? And if I'd asked that question when designing my custom screen reader, I would have never built it. The next question I asked is there new technology that could shift the capabilities of these tools? I certainly think so. But the key question is if there's new technology that could shift the capabilities of these tools to solve a new problem. All ideas start in the Genesis column. Most fail and stay there, but winning products move through the board as they gain more credibility and become more standardised. So, looking at this, there were two observations I made. First is that there's been a monumental innovation in web development. Practical access to your system's GPU directly in the browser. A website is run on a CPU. It has a few small computer units that are very good at processing complex software. A GPU, on the other hand, designed to run graphics, has hundreds of smaller units that all process the same code in parallel. It's also very good for running machine learning. Machine learning isn't one massive complex sequence of software. It's designed like the neurons in our brain. A neuron either fires or it doesn't, which isn't helpful on its own, but when interconnected with millions of other neurons, we can think and make decisions. I know that's a lot for this early in the morning, but machine learning works in the same way. It has millions of small mathematical operations that all run at the same time. So, when it's run on a GPU, it can be blindingly fast. And having this access to this computing power directly in the browser opens a lot of doors. We already had this access in a technology called WebGL, although this was more of a hacky solution and it forced the CPU to work in inefficient ways. WebGPU reinvented how the browser interacts with your system's GPU, making it faster with minimal CPU overhead, effectively making it a practical application. This is a game changer for machine learning in web development. No server to host the model, minimal latency, minimal lag on the website. This is a technology that started in the Genesis column and moved right as it gained more users and more credibility. The second observation I made was that all the current accessibility tools, they all share the same bottleneck, the developer. The screen reader is useless on inaccessible sites, and Lighthouse tools are only useful to the developers that know, care, and have the resources to consider. So, this begs the question, how can I leverage powerful machine learning in the browser to make accessibility a problem the user can solve, not the developer? That's it. That's the problem I want to solve. The natural instinct would be to start building and see where I can get with it. But as I mentioned, winning products are built on overcoming the reasons they would fail. So I came up with the 4 biggest reasons why this idea would fail. Machine learning predictions that are incorrect will quickly lose user trust, so I needed to build a system where the model can learn rapidly and spend a lot of time in training. Any browser extension that lags a website is dead from the start. I believe this will solve itself as WebGPU becomes more standardized and performant. I just need to use lightweight machine learning architectures. Also, I don't want this tool to come across as spammy. It should only help the user when they really need it. And finally, this isn't a tool to name and shame inaccessible websites. It's a tool to genuinely help user experience. So, with these considerations in mind, now it was time to build. I wanted to build the simplest possible working product, and I wanted to solve only one problem, helping users navigate visually cluttered, busy sites. So, let's look at the current solution. Taking Amazon as an example. Using a screen reader, it took 20 minutes to navigate through the entire content of a single product page. Just imagine trying to surf the internet, clicking back and forth through products. And this is Amazon. Imagine doing this on an inaccessible site, putting up with broken user journeys, confusing structure. If that doesn't drive you crazy, I think you may be related to Yoda from Star Wars. Now, let's have a look at the self-proclaimed world's first accessibility copilot. Once installed as a browser extension, it sits in the background of every website you visit and uses machine learning to detect visually cluttered, busy sites, and offer its assistance. Here, I'm on the product page. There's a lot of content to go through. The browser extension detects a lot of clutter, announces this to the screen reader, and offers its assistance. Here, I agree. It analyzes the web page to pull out the main sections of the content, and it then displays the user these sections in a list so they can click through and click the section they're most interested in. Here, I jump straight to the product description. I decide it's not quite what I'm looking for, so I pop the modal back open and I click through the sections, finding the similar items section so I can view a different item. Browsing the web just went from a confusing 20 minutes to a stress-free minute. The final consideration I wanted to touch on today was understanding your technology and knowing how to win with it. In this industry, the small details make all the difference. A system going down can ruin the reputation of a company. A bad user experience can lose a sale. And in the case of machine learning, it's all about data. Building a successful machine learning product will naturally attract competitors, but the more data and the better quality data you have, the bigger the hurdle it is for anyone competing with you. Also, a high learning rate will always be an advantage. Machines learn on the fly from feedback. They make a prediction, they evaluate how good the prediction was, and they learn for next time. And the extent to this advantage depends on how fast the feedback loop is. If feedback is generated quickly after making the prediction, the product will always have a sustained advantage because it's constantly learning. Take Google as an example. It predicts a list of useful links depending on a search, and the feedback is generated immediately when the user clicks on the most relevant link. Microsoft invested billions on Bing to try and compete with Google, but because Google had already been constantly learning for a decade, it was always impossible for Bing to catch up. So, knowing these niche differences that make or break products will be the difference between building a good product and a great one. This isn't a specific niche example. This talk has been a structured approach you can take into any process of your work. Start by mapping the assumptions you make around your tech stack. Question your assumptions. Look for opportunities to improve. Ask why that particular idea will fail. Start with the most basic form of that idea and experiment and fail often. And know and understand your technology and how to win with it to have that killer edge. Really appreciate everyone coming and getting up early for this talk, and thanks for Notts Techfast for having me. This has been a goal of mine to come do a talk. In fact, I have a mentor at work who does iOS talks all over the world, and he said to me, in a year's time you'll be doing a talk of your own. And that was 11 months ago. So if you guys don't mind, I'd like to take a quick photo just to mark the occasion. Don't mind. Sorry, you're not in there. Yeah. Awesome. Thank you very much. I appreciate it.